Hi guys, this is Mrs. Cerami with 9.5. We have 2 days to cover this, and then the senior lessons are done. So today we're going to talk about summation notation, and then we're going to apply it to arithmetic sequences only. So you're going to see this quite a bit, especially my seniors. You'll see this, well, maybe in Greek life. This is called sigma. And again, this indicates the sum. This represents the sum. And the Greek letter is sigma. So what that indicates is this symbol indicates that we're going to take this expression right here, whatever expression is given, and we are going to substitute. So K is called the index of summation, and we're going to put 1 in there and find that answer, and put 2 in there and find that answer, all until we get to the maximum number on the summation, and then add them all together. So it'll make more sense if we actually do a real problem. So this is my expression, and this is my index of summation. So we're going to substitute 1 in for 2k plus 1. If we substitute 1 in, we're going to get 5. If we substitute 2 in, we're going to get 7. And if we substitute 3 in, 3 is the maximum number we're going to substitute in for k, we're going to get 9. And the summation tells us that we're going to add all of the values together. So the answer to the summation from when k goes from 1 to 3, and when you're evaluating 2k plus 3, is 21. Okay, so that's the summation of it. So let's practice that a little bit. So we're going from 1 to 4. When you substitute 1 in, you get 4. When you substitute 2 in, you get 8. 3 in is 12, and 4, which is our maximum, k, is going to be 16. And when you add it together, I like doing shortcuts. That's 20 plus 20, we get 40. So we're not going to do all these, but I'll give you the answer to this one. If you want to try it on your own, this is 1. So what we have here is if you substitute 0 in, you're going to get cosine of 0 is 1. Substitute 1 in, cosine of pi is -1. Substitute 2 in, cosine of 2 pi is 1. Substitute 3 in, you're going to get cosine of 3 pi. Oop, I have to adjust my pen here. We're going to have cosine of 3 pi. Let's try that again. Which is -1. And then cosine of 4 pi brings you back to 1 again. So when you add this together, this gets zeroed out. This is zeroed out, so our sum would be equal to 1. If you want to try this one your own, the answer of this one's going to be 1. And then this one I really love because it goes into repeating decimals. So if you substitute 1 in, we're going to get 5/10. And if you put 2 in, you get 5/100. And 3 in, 5/1000. And 4 in, 5/10,000, and it keeps going because it actually doesn't have a maximum. It goes to infinity. So because it goes to infinity, just to look at this a little bit better, 0.5, 0.05, 0.005, 0.0005. This will end up being 0.5555 repeating, which is 5/9. Anytime you're repeating decimal, you put over 9, which we'll talk a little bit about tomorrow. Okay, next slide. We're going to do the opposite now. We're going to put it into summation, to sigma notation. We know we want to start at 1. The question is, how do we get our expression? The easiest way of doing that is just look for the addition. Look and see what you're adding. We are adding 4 to each number. So that's going to be your coefficient of n, and then figure out what you're adding and subtracting to get that. If you put 1 in, this is my first term, my second, my third, my fourth, etc. If you put 1 in here, we're not going to get 3, we're going to get 4. So in order to get 3, you have to subtract 1. Let's see if it works. If you put 2 in there, second term, you're going to get 8 minus 1 is 7. So that works. So this is what you're adding, you're subtracting, and then you have to substitute 1 in to see what you're going to get. Now, how do we get our maximum here? Well, what you're going to do is you're going to take this expression, and you're going to equal it to 43. So 4n minus 1 equals 43. This is going to give us our maximum n, or k. 4n equals 44, n equals 11. So our maximum here is 11. And again, see if it works. If you put 11 in there, you're going to get 44 minus 1, which is 43. So it works. Okay, again, you could pause any time and try it out, and then come back. We're adding 4 each time. So my coefficient once again is going to be 4m. If I put 1 in there, I'm going to get 4, but I need a 1. So I'm going to subtract 3. Let's check to see if it works. If I put 2 in there for the second term, 8 minus 3 is 5, it works. So we're going to start with n equaling 1, and to find what the maximum goes to, set the expression equal to the last term. So we get 4n equals 28, n equals 7. And see if it works. 7 times 4 is 28, minus 3 is 25. It works. Last one. This time we're adding 2 each time. So summation, we're going to have 2n, but if you put 1 in, you're not going to get 8, you're going to get 2. So we have to add 6. See if that works. If we put 2 in there, we'll get 4 plus 6 is 10. 3 in there. 6 plus 6 is 12. So that's the right expression. N equals 1. We need our maximum. So take that expression, set it equal to 20, and you'll get n equaling 7. See if it works. 7 times 2 is 14, plus 6 is 20. It works. So one of the things you're going to have to do is write summation notation. All right. Now, we're going to be finding sums of numbers, and we want to find the sum from 1 to 100 without a calculator. So let's do 100, 99, 98. So if you add the first and last term, we're going to get 101. If you add the second and second to last term, we get 101. Each pair of numbers, we're going to get 101. This would have been a really cool class discussion in class. So we're going to get a sum of 101, but the question is, how many pairs do we have? Well, we take the number, and we divide by 2, and we're going to get 50. So if you multiply this together, we will get our sum of 5,050. So instead of doing the pairs, you could just use the formula. So the formula, this is our a sub 1, and this is our a sub n. So if you add a sub 1 plus a sub n together and multiply it times the number of items, so we have 100 items here, divided by 2, you'll get your sum. So we're going to use that formula next. I do it a little bit differently in the book. That's how I do it. This is how the book does it. Again, I like to write it as a sub 1 plus a sub m times n divided by 2, because that's how we devised it. So we're going to do it in sigma notation and then the regular list. So we want to find the sum of arithmetic. This is an arithmetic, so the formula is a sub 1 plus a sub m times n over 2. That will give us the sum. So our a sub 1, substitute 1 in there, and you're going to get 4 plus 8, which is 12. A sub n, you're going to substitute 10 in there. So you're going to get 40 plus 8, which is 48. And we need the number of items, which they tell us that right there, because we're starting at 1, so we have 10 items. So just substitute that in. So we're going to have 12 plus 48 times the quantity of 10 over 2. So we have 60 times 5, which is the sum of 300. So instead of writing all the numbers out and adding them, you could just use this simple formula. It could be in summation or it could be in a list. So again, instead of trying to add it all up with your calculator, a sub 1 is negative 8. A sub n equals 27. The number of items we have is 2, 4, 6. So we're just going to add these two together. We get 19 times n divided by 2, and we get 57. It's a lot faster to do it this way. This one's a little bit harder, a little bit more stuff, because we know the first number is 111. And we know a sub n is 27. The only thing we're missing is n. Like, what is our n here? Well, you can create sigma notation. You can figure out the expression. So, because what we're looking for is our n up here. Like, what is it? We know that it starts at 1. So we're going down by 3. So negative 3n, if you put a 1 in there, you're going to get negative 3, but we need 111. So we're going to add 114 to get the expression. So to get n, you're going to do exactly what we did in the previous slide, is take that expression, set it equal to the last number, 27, and solve. And when we do that, we'll get negative 3n is going to equal a negative 87. And then n is going to equal 29. So n is 29 here. So when we're solving this, we're going to add 111 plus 27 times 29 over 2. So when you simplify that, we're going to get 2001. So again, if you don't know n, then you have to figure out n by finding the expression out first and setting the expression equal to the last number. That's as hard as it's going to get for this year. If it wasn't online, we would do more with this, but this is really good for this year. And you guys knowing for next year that sigma means adding sum, you add all the numbers together, that will be the big key. So for homework, you have a few problems on my math lab. Don't forget to note it in your notebook. You have a notebook quiz. You have to hand that all in via PowerPoint next Friday, and next Thursday is a test on this. So Friday, this is due Friday by 10 p.m. for my classes, and on Monday and Tuesday, depending on what block you're in, you'll have your last section, and then it's just a matter of reviewing. All right, guys, have a good day.